YouTube is often described as a video platform, but in reality, it is something far more complex. It is one of the largest distributed computing systems ever built, designed to store, process, analyze, and deliver video to billions of people in real time. YouTube, operated by Google, functions at a scale where traditional software design no longer applies. Every second, massive volumes of data move through global networks, data centers, and machine learning systems with minimal human intervention. When a video is uploaded, it does not exist as a single file in one place. It is broken into data segments and replicated across multiple data centers worldwide. These copies ensure speed, reliability, and fault tolerance. If one server fails, another instantly serves the same content. The system is designed not just to deliver video, but to survive constant failure. After upload, the video enters an automated transcoding pipeline. The original file is converted into multiple formats and resolutions, allowing the system to dynamically adjust playback quality based on device type, network speed, and real-time conditions. All of this happens invisibly, at massive scale. Delivery is handled by a global content delivery network. Instead of streaming from a central source, videos are cached on servers physically closer to viewers. When someone presses play, the data is typically delivered from a nearby node, reducing buffering and latency. This proximity is what enables instant playback across the planet. Above the infrastructure sits intelligence. YouTube's recommendation system is composed of many machine learning models operating together. These models predict which videos a viewer might click, how long they might watch, and whether they will continue watching afterward. Each recommendation is personalized and computed in milliseconds. Every interaction becomes data. Plays, pauses, rewinds, skips, and exits are logged and processed continuously. This feedback loop allows the system to adapt in near real time, refining predictions as human behavior changes. At this scale, learning never stops. But what happens when a creator deletes a video? Deletion is not instantaneous in a distributed system. When a video is deleted, YouTube first removes it from public access. The video disappears from search results, recommendations, playlists, and user-facing interfaces almost immediately. Behind the scenes, a cascade begins. Metadata references are flagged for removal. Recommendation models stop receiving new interaction data from that video. Links pointing to it return errors, signaling the system that the content is no longer available. Cached copies stored across the content delivery network are invalidated and gradually purged. This prevents the video from being served again, even if a server still temporarily holds fragments of it. The original video files and their replicas are then scheduled for deletion across data centers. Because copies exist in multiple locations, this process occurs asynchronously. Some fragments may persist briefly for redundancy or recovery purposes, but they are no longer accessible to viewers. Deletion is a controlled process, not a single action. Importantly, behavioral data does not disappear. Aggregated analytics, such as watch time statistics, engagement patterns, and historical performance, may persist in anonymized form. This data continues to inform system-wide learning, even though the video itself no longer exists. In other words, the content is removed, but the system retains what it learned from human interaction with it. From the algorithm's perspective, a deleted video simply exits the ecosystem. It no longer competes for attention. It no longer influences recommendations directly. Its role in the system ends, quietly, without disruption. The system itself continues uninterrupted. Tasks are redistributed. Caches refresh. Models update. This resilience is a defining feature of distributed systems at scale. What makes YouTube remarkable is not any single technology, but the integration of all of them: global storage, adaptive streaming, machine learning, real-time analytics, fault-tolerant infrastructure, all operating continuously across billions of users. In the end, YouTube does not function as traditional media. It functions as data, stored, routed, predicted, and optimized. And once you understand that, even deletion becomes part of the system, not an event, but a process. If you enjoyed this video, don't forget to subscribe, like, and comment. Your engagement helps the channel grow and helps these ideas reach more curious minds just like yours. Let us know on the comment what topics you'd like to see next, because in science, there's always more of this and that to discover. Thanks for watching, and we'll see you soon.